be convinced, yeah, something right has happened at the end of 3 months. So that's the that is the approach that has been working very well for our organization in Soothsayer, but I believe it is generalized enough. One last comment about what infrastructure that you should focus on. SAS, I think, is the industry leader. SPSS is the IBM product. These are all excellent. 5 years back, I would have said, depending on what your organization has, just go for it. And however, now I changed my opinion. I strongly recommend to any organization interested in building a data science team to actively encourage their teams to explore open source options, R and Python. Now, let me justify why. One obvious reason that everyone says it's cheap, but this field is exploding. The growth in this field is just unbelievable. Just to give you an example, 3 years back, I was actually engaged by a firm to do Twitter-based sentiment analysis. Look at our product on Twitter and see whether people are talking positively or negatively. I was paid to solve this problem. Today, in my institute, that's a classroom homework. They have to solve it in the afternoon session and go home. So there is now a library that just pulls 50,000 Twitter feeds. Another library that just does sentiment. So it's a 10-line code, and you have a nice chart that is dynamically updating itself. So the field is exploding, and commercial packages, obviously, they have a strong team of data scientists, your 100, 200 data scientists that produce this. The open source guys, there are 20,000 of them, or 200,000 of professors, scientists, just doing their pastime building these models. Just to give you an idea, SAS probably in its minor has around 100 models, and R in the last count has around 20,000 models. So what I recommend, you can, they have their own advantages. I mean, SAS, all the commercial products come with maintenance, all that good stuff. Easy user interface and all that. But the field is exploding so much, so to solve the problem, if you want to build a deep learning model, or if you want to build a spectral method, whatever is the advanced nonlinear things that I mentioned, an R and Python will enable you to do it in 2 days at no cost. If you find a lot of value in that, then figure out how to code it or how to acquire it from your commercial partner. But it is extremely important that your data science team practices open source, be on the cutting edge, uses the latest and the best, finds that there is a value for solving your particular problem with that latest method. Then if you want to go in a commercial product route, then search for the right product and put it, build it in that. But in the experimentation phase, it's extremely fast. And organizations are also becoming very savvy about this. 5-10 years back, if I go to a Fortune 100 and say I will use an open source to solve your problem, they'll frown. Today, they're appreciative. They say, yeah, go ahead, do the analysis. This is worthwhile. It's cheap. Much more important, it allows you to be at the cutting edge. I mean, something that was developed in 2014 September, we already see that, and we can implement it in our product. So that's essentially what I recommend from a infrastructure and team stack. So it's a different way of solving problems. It's nicely maturing, catching up. You can definitely expect disruptive growth in some of the complex problems that you're working on. And that's what we wanted to cover today from Soothsayer. Okay. And any questions you have, I would love to take them and answer. I'll come to you. Yeah.
So Apache projects are open source too? Is
Yeah.
there a reason R and Python are recommended more than Apache projects?
No. Apache is probably about engineering, that Hadoop and everything. They are anyway open source, the Giraffe, all that new things. R and Python have predictive parts. So there are two components here, right? One is putting the big data together. Apache is wonderful. Then you have R and Python to build predictive analytics on top of that. For that, I recommended R and Python. Okay. Yeah.
Can you talk a bit about these were analytics projects which were a 3-month duration. You created a model and you kind of gave the insights as a result. But what about inline analytics, where we are running this in a automated fashion? The expectation of the industry is predictive analytics will show up on a war room dashboard and you will immediately react to it.
Yeah.
I mean, eyeballs are still needed, but it's happening in a closed
Automated
loop.
fashion, right? Yeah, this is much more complex. And then what is the longevity of that model? When should
How do you
die?
adapt that
How
model?
do you adapt and how do you kill? So one of the projects that we worked on was for a pharma company. We were looking at clinical trial and fraud in clinical trial. So this company has around 1,000 drugs that are being clinically trialed at any given point, and each drug has around 500 people that on whom they are testing. So at any given window, some 200 to 300,000 people went to their doctors, and around 60 parameters are measured after giving the drug, and they are given. So the idea here is there is a scope for fraud if the doctor or the hospital system gets paid if the patient goes through the entire cycle. Let's say it's a 12 weeks. It gets paid if the patient goes through entire 12 weeks. But let's say on the 9th week, for some reason, weather was bad or something, the patient couldn't come to the hospital. Doctor knows very well that he will come in 10th, 11th, and 12th weeks. So there is a chance that the doctor can swab the some other patient's urine sample, say this is this patient's urine sample. I believe that happens. It's a bit scary, but there is a chance that 1 or 2.1% of it being fraud. So this is your war room kind of analysis, right? So there are hospitals where every week these tests are done, and then those tests are uploaded into a database where you have these millions and millions of records from all over the globe of various medicines. From there, your analytics engine just pulls that week's data and a bit before, because I have to look at a moving sliding window, and identify, do the fraud analytics, identify the transactions that are most likely to be fraud, and then push it to a BI system that they have, where the business experts are looking at each of the transaction and say, okay, if this is fraud, then this is fraud, likely to be fraud. Then they have to send an auditor to audit, and the system automatically has to identify who is the best fit auditor, not only based on geographical proximity, but based on the skill to identify that specific fraud, and then recommend and then schedule it automatically. So now I didn't mean that all that will be done in 3 months, obviously. But the point here is we still divided that into 3-month windows. So we said first 3 months, let's get the fraud detection. So given a static set of data, we were able to identify fraud a lot more accurately than before. The next 3 months was about identifying the right auditing guy. Then there is an engineering component. Then there is a build. So overall, it took probably around 12 to 15 months. But the where I get particularly uncomfortable is there's no measurable win anywhere in between. So let's wait for 15 months to get the thing. It's very uncomfortable. Let's divide this project like this. First 3 months, let's focus on this. Next 3 months, let's focus on building auditing. Next 3 months, actually the big data part. Like that that's what I meant.
But when implemented, this thing ran in a closed loop. It was
Yeah.
a fully functional integrated system, right?
Yeah.
It may take you 3 years to build
No.
it. I mean, I'm not worried about that aspect as much as the fact, as Citibank coming to me and saying, you know what, I want you to be able to look at documents of shipping manifests when a ship leaves Indonesia and is about to arrive into New Jersey, okay? If it makes a wrong detour and stops somewhere in a port in Africa and unloads some cargo, I want that to be flagged based off the credit note that we gave to the shipping company.
Yes.
So the journey of the ship is 10
6
days
months, yeah.
or for 3 weeks. In that 3 weeks, it's supposed to follow a particular pattern, touch certain ports. But if it takes a route
Yes.
different from that, we are supposed to flag it, right?
Yeah.
And
So it is a closed loop system.
it's a closed loop system.
Yes.
The way it is supposed to be flagged is through documents that ships
Yes.
submit, right? Customs
Yeah.
manifests and things like that, or cargo manifests. And those documents come back in. You interpret the
Yeah.
meaning of the document,
Yes.
whether it fits into your expected profile.
Yeah.
This closed loop system is not a project that's done in a 3-month window and given results are given. It's a system which
Yeah,
will
yeah.
operate for
Yes,
years
yes.
thereafter.
Yes. Even more, sorry, please go ahead.
So where is the hook of the analytics engine continuously, this continuous loop of sucking in data, performing the whatever models are done, flagging the results? It sounds like when a data scientist works, he has to clean this up. How do I automate all of that is the thing. How did
Well,
the data
that-
scientist walk
so-
away from the problem?
Okay, so the point is we take some amount of data and build the model, okay, using our practices, and then validate it. Now that we document exactly what goes, and we build that cleaning system separately. So there is a cleaning system, then there is a predictive engine, and then there is a storytelling, what dashboards we have to do. All three have to be separately built. And much more important and interesting thing is, when should I kill this model? So the guy knows if I take a detour in Africa, they're catching now. That guy is also smart, he has to make a living, right? So he will now start throwing probably the cargo without taking a stop, and someone else comes. So the model that I built becomes irrelevant. It could be because of any reason. The market changes, let's call them. So the engine also has to have a self-learning mechanism where at least it knows that it's not working. So what we do is we get some insights. Any insight will be validated at some point in the future. We say for this particular product, women 35 to 40 are bad customers. But then let's say it was valid for some time. After some time, actually for some reason, women 35 to 40 start buying it. We loop that back into the system. Now the system knows that, hey, you know what? The model is not working. At least this particular pattern is not working. And then it builds enough evidence. One-off case could be an outlier. It builds enough evidence. At that point, when there is enough evidence for us to tweak, now you have to either tweak the model or you have to rebuild the model, revamp the model, so that longevity is becoming more and more important in the changing market scene, where 10 years back a model lived for 5 years. Today probably some models live only for 5 weeks. And you have to be constantly aware of whether you have an outdated model. That is because that's driving some business decisions. I'm telling these customers don't make value, and maybe they are. So that also has to be pointed out. Yes, sir.
Thank you.
Yeah.
Implicit to a lot that you said, you actually said in the beginning of your presentation, is the issue of accuracy. Can you speak more on that? Are there tools? What sort of tools are good tools to determine your accuracy, which is a
Yeah.
huge questionable word?
Yes, yes, yes. Very, very correctly so. So the first question is, what is accuracy? So if I'm a doctor and 1 in 1,000 patients have cancer, and I write a model that says nobody has cancer. Interestingly, I have a 99.99% accuracy in the model. I only make one mistake, right? If I tested 1,000, truly 999 didn't have. So the first step that any data scientist has to do and tell the business user is what accuracy metric that they are choosing and why they are choosing so. So in this,
Is it the data scientist?
yes, it is the data scientist.
Documentation, or is it the business person?
Data scientists typically recommends because the metrics are statistical, but they have to explain that metric in a business term to the business user. But data scientist typically takes the responsibility of identifying the most suitable, meaningful metric that explains the goodness of the model. And the business user has to be justified completely. In fact, when I get engaged with a client, in the first week, we present something called a blueprint, where we write our understanding of the problem and then explain the error metric that we have chosen, why we have chosen, why we believe that is important, and then get a validation from the client. The second step, when you give me some data, I make it into 3 splits. One split I use for building the model. Now, I never ever measure the goodness of my model on the same set. Okay, because I know my job is not fitting the best model that works on data in hand. I have to fit a model for data I don't see. So I lock down one set. Another one I test. If it's not working well, I will tweak it. Again, rebuild the model on this, test it on this, rebuild, test, rebuild, test. Finally, I get a model that has same accuracy on both. Then I go and actually measure the accuracy on this. I only report the value that I get here to you. And what I normally recommend to we normally recommend to our clients is, we ask them to keep one more set of data with them that they haven't exposed us to. What this model is able to do on that particular data set in front of you is what I'm really confident that it works for the unseen data. So 1980s and 90s, several major mistakes have happened because the practice has not matured as much. But now, any data science team that knows what it is doing actually never ever starts the project without defining a good error metric, and will always do out of the box validation for the model that is built. But it's a very, very relevant question. It's good that you asked. So please ensure that that's always in your radar when you're building these models. Okay. If there are no more questions, thank you very much for attending. And yeah, we'll stay in touch.